I mentioned this yesterday, but this used to not be a Calc AB topic. It used to just be a Calc BC topic. So we're actually looking at some free responses from the BC test. And so you might notice that we have something called Euler's method, which is not an AB topic. So we're not going to talk about it. We're going to focus on part B, which is finding this limit. And we are going to make sure that we are following the steps First off, we need to know that the top and the bottom are differentiable. How do we know that the top is differentiable? Oh, it says so. It says differential equation. Do we know that x cubed minus 1 is differentiable? Yes, we do. That's polynomial. It's got to be differentiable. I can take derivative of x cubed minus 1. So, f of x and x cubed minus 1 are both differentiable. Okay? There's thing number one you need to say. Thing number two is you need to check limit of the top and limit of the bottom. So checking these two things gives you a point. On this AP test, the scoring was that this was 2 points. 1 point for explaining why we can use the L'Hopital's rule, and a point for the answer. These are both 0. How do I know this one is 0? F of x? Well, I know that because f of 1 is 0. So if I plug in 1, I get out 0 on the top. And then same thing here. If I plug in 1, I get out 0. 1 cubed minus 1 is 0. Therefore, our rule can be used. So let's do our rule. I want to remind you one more time that this is different from the quotient rule. The quotient rule is low d high minus high d low over the square of what's below. This rule is just saying that the limit of the function is the same as the limit of derivative of the top over derivative of the bottom. We are not doing the quotient rule here. So derivative of the top is f prime of x, derivative of the bottom is 3x squared. And this was similar to one we did yesterday. The limit as x approaches 1. F prime of x, well, we know what f prime of x is because we're told what dy dx is. Dy dx is 1 minus y. So 1 minus y is going to go on top, and a 3x squared is going to go on the bottom. And now we can plug in our point. So we can plug in 1 for x. And then we can plug in for y. What are we plugging in for y if we're plugging in 1 for x? 0, because f of 1 is 0. 1 minus 0 is 1. 1 squared is 1. 3 times 1 is 3. There's our answer. So we made sure we said it was differentiable. We checked the limit at the top, limit at the bottom to make sure we got an indeterminate form. Then we said we can use our rule. Part C of this question, which I also want you to try because you should be able to do it, is to find a particular solution to the differential equation. That means we're using separation of variables on that problem and getting what the original function was. So you should be trying that one too. Same thing down here. You should be able to do part A. You are not expected to do part B. You should be able to do part C.